Good morning, ma'am. My name is T. Bashit, and today I am going to explain how compilers, interpreters, loaders, and linkers work. These compounds play a major role in converting the programs we write into something a computer can understand and execute. Introduction. We write high-level programs in languages like C, C++, Java, and Python. However, computers only understand mission languages which consists of binary zeros and ones. So that to run our programs efficiently, we need tools like compilers, interpreters, loaders, and linkers. By the end of this presentation, you will understand how each one works and why they are important. Software development overview of compilers and interpreters. A compiler translates the whole source code into machine code before execution. An interpreter executes the program line by line during runtime. So the key difference is compilers focus on speed and efficiency. Interpreters focus on flexibility and easier dubbing. Next, compiler process. Let's understand what a compiler actually does. When we compile a program, the compiler performs multiple steps like lexical analysis, reads the code and break it into tokens. Syntax analysis checks if the code follows the correct grammar. Semantic analysis ensures logical corrections. Optimization improves code performance. Code generation produces mission code. The output of a compiler is an object file or an executable file. Interpreters in depth. Interpreters translate and execute the program line by line because results appear immediately. This helps in uh, big testing, debugging, fast learning. Languages like Python, JavaScript, and Ruby use interpreters. That's why they are very popular for rapid development and programming. Next, loaders. Once the mission code is generated, it has to be loaded into memory before execution. The tool that does this is called a loader. A loader allocates memory for program code and data, sets up the execution environment, transfers control to the program so it can run. Without a loader, an executable program cannot run. Linkers. Linkers in programming. Large programs are normally written across multiple files. A linker combines these objects files into a single executable. A linker also connects external libraries like math or graphics libraries, resolves memory addresses. In linkers, there are two types. There are static linking, dynamic linking. Static linking links libraries at compile time. Dynamic linking links libraries at runtime. Next, compilers versus interpreter. What is the difference between compiler and interpreters? Means compiler-based programs run faster because the whole code is pre-translated. Interpreter-based programs run slower but provide real-time error detection and easy debugging. So compilers are suitable for performance critical applications while interpreters are great for scripting and learning. Next, next, how to compile a program means write source code, create your program using a high level programming languages like C, Java, or Python. Save the file with the operate extension and run the compiler. Execute the compiler on your source code file. The compiler will perform lexical and syntax analysis to check for errors. Generate mission code. If the compiler finds no errors, it will generate mission code that the computer can understand and executable. And next, load the executable. Use a loader to load the generated executable file into memory, preparing it for execution by the operating system. Next, the real-world examples. Here are some real examples. GCC is a well-known compiler used for C and C++. Java uses both the Java and compiler and the JVM interpreter, making Java programs platform independent. Python uses CPython interpreter, which supports dynamic typing and is widely used in data science. Next, the key takeaway. In summary, understanding compilers, interpreters, loaders, and linkers is crucial for software development. Compilers translate high-level code into machine language, while interpreters execute directly. Loaders manage program execution, and linkers combine multiple code files. Together, they enhance performance and efficiency. As you advance in computer science, mastering these concepts will empower you to write optimized code and troubleshoot efficiently. Embrace these tools to become a proficient developer in the evolving tech landscape. Thank you. This is presented by Bashit in CADA section.